Welcome back to Space Reviewed. I'm Andy. This time, I'm going to be looking at this bad boy, the KH-9 Hexagon, a series of US spy satellites. One of their most important jobs was checking up that the USSR wasn't breaking any of the agreed conditions of various nuclear treaties. You might have heard the US's various spy satellites referred to as National Technical Means, or NTM. That's because of the history of these satellites as the US national technical means of verification that the USSR wasn't up to mischief. The KH-9 Hexagon satellites were imagery intelligence satellites. So they took photos like this declassified one of the Eiffel Tower. As you can see, the resolution was pretty good. And by that, I mean the spatial resolution, the smallest object or separation between objects that can be detected. Here you can make out the ironwork of the tower, the boats on the river, and even vehicles on the surrounding roads. Of course, this was well before the advent of the digital camera, so the photos these satellites took were on film. A lot of film. Each satellite carried almost 100 kilometers of film. To see the photos, the US needed to get the film back from space and develop it, which is where this comes in. This is a specially modified plane about to catch a film canister in mid-air. The film was wound up into the canisters, which were ejected from the satellite at a chosen time, re-entered the atmosphere, and used a parachute to slow down. Then, rather than allowing them to hit the Earth, potentially breaking the canisters and ruining the film, or even falling into enemy hands, the US Air Force caught them, a spectacular feat of timing and flying. Of course, having such a complicated system made it very expensive, even on top of the vast cost of the satellites and the launches. Back to the photograph. The spatial resolution is actually pushing up against the limits of physics, or at least it was by the end of the Hexagon program. The resolution is dependent on the size of the imaging system, which is limited by the size of the satellite, which is limited by the size of the rocket. The biggest rockets haven't got much bigger since the 1970s. So the best spy satellites today don't actually have hugely better spatial resolution than this, but they do have improved resolution in other ways. One way is colour. A black and white photo uses light from all parts of the visible spectrum. A colour photo divides the spectrum into separate colour bands, giving you more information. Towards the end of the Hexagon program, the satellites started using colour film for that very reason. The left-hand side of this image shows a modern, digital, colour satellite image of Emi Koussi, a volcano in northern Chad, in the Sahara Desert. But why stop at just dividing the spectrum into the red, green and blue bands needed to get a colour photo? We can now make sensors that are focused in on much smaller spectral bands, and that go beyond visible light into ultraviolet at one end and infrared at the other. That even greater spectral resolution gives us more information. Because different chemicals have distinct appearances in different spectral bands, we can start to understand what things in the picture are made from. The right-hand side of this image has used high spectral resolution imagery to classify the rocks on the surface by type and adjust the colour accordingly. So you can see the round shield of the volcano is igneous rock in green, while the surrounding desert is sedimentary rock in red and yellow. Another form of resolution is time. Reducing the time between photographs of the same place increases temporal resolution, allowing us to spot changes more quickly and understand more accurately when they happened. In the extreme, you can also capture video from space, allowing you to calculate the speed and the direction of moving objects in shot, among other things. These days, it's not just superpowers who can afford to operate spy satellites. There are a whole load of companies out there operating imaging satellites of various sorts. Some of them, like Planet here, offer value-added services like automatic monitoring and change detection, with the option to also automatically task a higher resolution satellite to image the changed area and figure out exactly what changed. This service is available to pretty much anyone who can pay for it. Other firms go further still, using algorithms to analyze the images and tell you what they mean. You can buy access to analytics based on satellite imagery that will tell you how successful your retail store is, how much gas is being stored in China, or what the health of this year's corn crop in the US is. You can also track when ships enter or leave port, detect vehicles hidden in a forest, or see things under the sea so long as it's shallow and the water is clear. But I've veered away from the subject of my review here, so back to that. The KH-9 hexagon was pretty awesome, certainly the catching the film in mid-air part. As part of the system that upheld nuclear treaties, it did also play a part in stopping the Cold War getting hot, and certainly in putting an end to the kind of nuclear tests that did for Ariel 1. On top of that, the spatial resolution was really very impressive, almost as good as today. But all that came at a massive cost, and I'm going to dock a star for that reason. I give the KH-9 hexagon 4 stars out of 5.